students, and welcome to today's lesson. I'm Miss Lee. Today, we will continue to investigate the question, how can we describe an object's motion? Are you ready? Grab your pencil and your science journal, and let's get started.
I have two different balls, a tennis ball and a ping pong ball. If I release both balls at the same time and from the same height, what do you think will happen? What have we learned about motion so far that can help us answer this question? Let's start our class anchor chart to help us review what we know. What should we add about motion? Oh, we know that making observations, including taking measurements, helps us describe the motion of an object. We also know that a description of an object's motion usually includes the object's speed and direction. An object that is not moving is described as at rest. Your first task after this lesson is to update the anchor chart in your science journal. All right, let's look at the balls again. Watch what happens when we release these two balls. Think about what you know about motion. Are you ready? What similarities do you notice in the motion of the balls? I will play the video clips again. Do you notice that both balls move up and down several times, and each time the balls bounce a little lower? And do you notice the balls move at a similar speed, hit the floor at the same time, and then slow down at about the same time until they finally come to rest? At first, the balls fall quickly. Then the balls change direction when they hit the ground. The balls bounce. When the balls fall back down, they keep bouncing, but each bounce is a little lower than the last bounce. Finally, the balls slow down and eventually stop moving.
Do you think both of the balls had mechanical energy? Why or why not? Maybe you said yes because both balls were moving. I agree. Both balls fell and then bounced up and down. But do you think both of the balls had mechanical energy before they were dropped? Why or why not? I'm not sure. Can something have energy if it is at rest? Well, energy is necessary to make something happen. And something happens when an object starts to move. We know that the balls were at rest before we began to move. So that tells us that an object can have mechanical energy even if it is not in motion. So the balls in our sketch have mechanical energy when they are at rest and when they're moving. Wow, our sketch helps us understand that the balls have mechanical energy. Do you think our sketch can help us predict the motion of another ball?
What about this bouncy ball? If I drop the bouncy ball, how do you predict it will move? Perhaps the ball will fall quickly and then change direction when it hits the floor. Or maybe the balls will bounce and the bounces will get lower and lower. The ball will eventually stop moving. Hey, we just predicted the bouncy ball's motion. How are we able to predict the ball's motion without observing it? We were able to predict the ball's motion because we observed the motion of the other balls. We saw that the balls bounce in a similar way, even if they are different kinds of balls. The way a ball bounces follows a pattern. A pattern of motion is when an object moves the same way over and over. Can you think of any other objects that move the same way over and over? What about pendulums? Call out any patterns of motion that you notice. Do you notice any motion that is happening over and over? Yeah, the pendulum moves back and forth. Let's say the pendulum swings back and forth many times. This motion is a pattern. What else? Do you notice the swings start long and get shorter until the pendulum stops moving? That motion is also a pattern. Can you think of a name for this pattern of motion? I know. Let's call this motion swinging. Think about the patterns of motion that we saw for the ball. What can we write? We can write that the ball falls when it is dropped. It bounces off the floor, then it bounces lower and lower each time until it finally stops. So, can you think of a name for this pattern of motion? Let's call this motion bouncing. What patterns do you remember from the car station? I remembered that the car rolls in a straight line across the floor. I also remembered that it starts fast, then it slows down and stops. We can use the word rolling to describe the pattern of motion. What patterns do you remember from the spinning toy station? I recall the top spins around in a circle. It starts fast and then slows down. It eventually falls over and stops. We can use the word spinning to describe this pattern of motion. What other motion station did we observe? Oh, that's right, the ramp station. What patterns do you remember from this station? Do you remember that the block slides down the ramp in a straight line? I also remember that it goes fast at first, then it slows down and stops. I think the word sliding describes this motion. Let's think about the catapult station. I remember that the cotton ball flies through the air when it is launched. It travels through the air in an upside down U shape. It lands on the floor, bounces a little, and then stops. Let's use the word curving to describe the pattern of motion. Look closely at our full chart. What similarities do you notice in the patterns of motion for all 6 stations? One thing I know is that at each station, an object starts to move, but then the moving object eventually stops. Did you notice that too? How do these patterns support what we have learned about describing motion? Think about some of the words and phrases we have used to describe motion. I think the patterns show that we can use an object's speed and direction to help us describe the object's motion. And we can describe how all the moving objects also came to rest. Now it's your turn. Each of these photographs show an example of an object that moves. Can you match the motion in each photograph to one of the patterns of motion from our chart? Sliding, rolling, curving, bouncing, swinging, or spinning. I'll give you 10 seconds to think. Go. Time's up. Let's look closely. Starting with these 3. In this photograph, the sled slides down the snowy hill. So it has a sliding motion. The pinwheels spin when you blow on them. So they have a spinning motion. What about dribbling a basketball? What type of motion do you see here? The basketball has a bouncing motion. 3 more photographs left. Can you match the last 3 patterns of motion? You swing on the playground rings. The wheelchair has a rolling motion, and the slingshot has a curving motion like a catapult. Guess what? We were able to classify the motion of these objects just by looking at photographs. We didn't actually see the objects move. We were able to classify the motion because these objects are similar to the objects we observed at our motion stations. For example, the pinwheel is shaped kind of like a game spinner, and the playground rings look a little like pendulums. So we can predict that the pinwheel and the game spinner will move in the same way, and so will the rings and the pendulum. Do you agree? The examples of the photographs fit into the patterns of motion we described, but not every example of motion fits these patterns. Can you think of an example that doesn't follow one of the patterns in our chart? Are there patterns of motion other than swinging, bouncing, rolling, spinning, sliding, or curving? Watch this video clip of hummingbirds feeding from a bird feeder. Does the motion of a hummingbird's wings match any of these patterns of motion? No. Do you see how different hummingbirds move their wings at different speeds? They fly in so many directions. So now we know not all motion can be described by using just these 6 words. We are learning a lot to help us answer the question, how can we describe an object's motion? Let's update an anchor model about the motion of a soccer ball. Let's add our new knowledge, starting with the ball on Earth. We said before a kick, the soccer ball is not moving on the grass. Now we can say that before a kick, the soccer ball is at rest on the grass. Before we said that after a kick, it rolls across the grass. Let's add that it rolls in a straight line across the grass and that it slows down as it rolls. It eventually stops and is at rest again. Now for the International Space Station. Before we said that during a kick, it starts moving away from the astronaut. Now we know that during a kick, it moves in a different direction. Your second task today is to update the anchor model and explanation in your science journal. So what information would help us better describe and compare the motion of a soccer ball on board the International Space Station with the motion of a soccer ball on Earth? I think it would help to have measurements to compare the soccer balls, such as how far soccer balls travel in a certain motion of time. We can't go to the International Space Station to make measurements, can we? But imagine you are an astronaut in space. What information do you need to predict the motion of a soccer ball? Your last task will be to answer this question. But for now, I think we need a little more practice investigating patterns of motion on Earth. In our next lesson, we'll do just that. Let's review your tasks for today. First, fill in the blanks to update the anchor chart. Second, update the anchor model and explanation. Third, answer the question about predicting the motion of a soccer ball.